Everything is set, so let's start with the programming part. Before we start writing program, first thing we need is a programming environment. Now it allows us to write a program in a way that is easy for you to write them, and then it will convert the program into a readable format that microcontroller can understand. So you require to download Atmel Studio. You can visit Atmel's official website and download it from there. They will ask you for registration. After registration, then you can download it. They also has a tutorial on how to download and install the Atmel Studio, and also tutorial on how to use it. So after downloading and installation, open Atmel Studio. First thing we have to do is to create a new project. You can do this by clicking over here or go to File, Project, select C, C++, GCC, C executable project, give the name for your project, and save it. Click on OK. Select the part number you are going to use. We are going to use Atmega 8 microcontroller from Atmel. So we are going to select Atmega from the drop down menu, scroll it down and click on Atmega 8. This part contains the basic information about your microcontroller. If you want more information, you can download a datasheet by clicking over here. Click OK. When you create a new project, it will IDE generate automatically this skeleton code. Now we are going to use this skeleton code in all the program for all the tutorials. Let's see what they have generated. Now this part which is written in green color are called comments. Now I will explain in a while what these comments are. So I will delete it first. Now the first line we are going to write or gonna put in all the programs is called the include statement for avrio.h. that is a header file. The one which we are writing now is called .c file. This one is the header file. Now these header files or library files contain lots of code that we don't have to write. It also contains information and definition for the AVR line of microcontroller. Then comes the main routine. This is the main routine. These main routines are the entry points for the program. These are the main part where the actual execution starts. I would like to introduce how to make notes in the programming, and this is a really important concept to provide information in the programming that won't be used in the running of the program, but will inform you how you wrote it and why you did certain things in the program. There are two ways actually to write the comment. One is the single line comment. We write that by using double forward slash, and we have to say in plain English term whatever notes you want to make. For example, I will write a comment on the top of this page explaining what you should expect in this page. So I will write the name of the robot which we are making, single sensor obstacle avoidance robot. So these programs are these lines comments are in the program file, but that won't be used in generating the .hex file which we upload to our microcontroller. So these are single line comments. If you want multiple line of comment, you can use these forward slash asterisk and close your line with the asterisk forward slash. So you can write any number of line of comment between these two tags. For example, line 2, line 3. You can put any number of line of comments between these two texts. So let's start writing program for our obstacle avoidance robot. We are going to use the flow chart which we have made earlier. This was our flow chart. Take reading from the sensor, check if there is obstacle or not. If yes, then turn left. If no, then move forward. We are using one digital IR sensor. It has only two possibilities, either 1 or 0. 1 if it detect any object, 0 if it does not. Which means if sensor detects any object, it will send binary 1 to the microcontroller. If not, it will send 0 to the microcontroller. This section will go inside this infinite loop part, that is this while loop, because once the microcontroller checks, it has to again go to the take reading section, and again it will check if the obstacle is detected or not. So this should be repeat again and again. That's why it has to go inside this infinite loop part. Before we start taking reading from the sensor, first we have to do some initialization. That initialization will come about this while loop. We have to declare the pin as an input or as an output. We have to declare the pin which we are going to use, and whether that pin is an input or is an output. We are using motor, so we have to declare that pin, the one which we have interfaced it with. Actually, we interface our motor driver, and with the use of that motor driver we drives our motor. So we have to declare that pin as an output, and we are using one sensor, so we have to declare that pin as an input. It's very simple to declare any pin as an input or output. We have to use, or we have to write a specific register called DDR register, that is called data direction register. Now we have 3 ports in our microcontroller, 8 megahertz B, C, D, and each port consists of 8 pins. So we have this register of 8 bits of 1 bytes. Each bits is associated with each pins of that register. Associated with that pins. There are 3 different register associated with each pins. One is port register, other is pin, and the third one is DDR, that is data direction register. This register is used to set that pin as an input or as an output. Pin is used to get the input from that from that pins, and port is used to send output to that pin. For example, we send 5 volt or 0 volt to the pin. We can achieve this by using this register. In order to do anything, we just have to write a value on this register. We can write only 1 and 0. We will see this about this port and pin later. First we will deal with this DDR register. So in order to set as an output, we have to write this register with 1, binary 1. If we want to set any pin as an input, we have to write 0 to this register. This X represent B, C or D. So we are going to declare our port D as an output, because we have connected our motor driver to that pin. So DDR D equal to, now there are many ways to write this register or any of the register, but we are going to use binary notation. So 0B stand for binary, and 8 times 1. Then we have to end this block or line with semicolon. We have written 8 times 1 because we have set all the pins of the port D as an output. The first pin, that is in binary, we start our indexing with 0. So we have to count 0 to 7. The 0th pin is this one, the most right hand side. Then comes the 1, 2, 3 till 7, 0 to 7, so total 8 pins. We will make a small note, setting port D as an output. Next we have to set port C as an input because we are interfacing our sensor with that pin. We have connected the sensor, the one IR sensor, to pin C0. So DDRC equal to 0B and 8 times 0. In 8 MHz, port C has only 7 pin, that is from 0 to 6. So we have to delete that, the most left hand side, that is 8 pin. It is okay if you write that, but remember not to take any input or output from that pin because we don't have that pin in 8 MHz. We'll note setting port C as an input. Perfect, we are done with the initialization. Next thing we have to do is to create a variable because we are going to take a reading from the sensor and use that value. So on the basis of that value we are going to make a decision. If 1, then turn left, if 0, then move forward. So we have to create a variable. Now variable is like the one which we use in math. It is used to store the value and its value can be changed. So that's why its name is variable. In order to create a variable, first thing you have to write is the data types. Now data types define what kind of data you are going to store in that variable. We are going to store either 0 or 1, both are the numbers and also the positive number. So the data types we are going to use is integer, that is I and T. Now this integer data types can store both positive and negative value, but not the fraction value, the one which we have, one with the decimal point. So it will do because we are going to use 0 and 1, both are number without decimal. So int, now we have to give the name for our variable. You can use numbers or you can use letters, capital or small and underscore. So we will give name sensor. So we have defined a variable called sensor, which name as sensor, and it's of data types int. So it can store the value positive or negative numbers. Now when you define this line, we define a variable, memory is or object is created. Now the size of that object depends upon the data types you are using. We are using int, so it will be of 2 bytes or 4 bytes depending upon your system. In my system it's of 4 bytes. If we see our memory layout, now each block represent 1 bit. So you can store either 1 or 0 inside each blocks. 1 byte consists of 8 bits. So here in my system int is of 4 bytes, so in total 32 bits. So when you define this variable, all these 32 bits will be named as word sensor, that is variable sensor. We are going to write all these inside the infinite loop section. So our first part would be taking reading from the sensor. So we are going to put some value inside the sensor, the variable which we have declared, sensor equal to. If you want to take input, you have to read it from the register called PIN, pin. Depending on the pins you are using, you can write pin C, pin A, pin B, anything. So we are going to take input from the sensor which we have interfaced with pin C0. So we are going to read from the pin C register and mask it with the value, so that we will get the input from only one pin, that is pin C0, 0B. Now this line help us to get input from only one pin, that is pin C0, the where we have written binary 1. So this line mask the input from all the input, because pin C register has the information about all the pins. Now this line will mask and give us the input of only one pin, that is pin C0, where we have connected our sensor. Rest will be set as 0. So after ending operation, no matter what information stored in other pins, it will be 0. So we have taken reading. Now comes the checking part. The equivalent part of this symbol in the programming language is if else statement. So we will write if else. Now inside the if loop, if statement, we are going to check if if obstacle is not detected, or if obstacle is detected or not. So the way to check this is by writing sensor equal to. Now I have written 2 equal to, because in programming language this equal to is not the one which we are using in math. The one which we are using in math is this, we have to write 2 times equal to. This one is called assignment operator, because we assign something to left hand side. So we will check if the obstacle is detected or not. We are going to write this statement in the if statement. So we have to check if the sensor is sending 0 or not. So 0B 7 times 0. So this will check if the sensor is sending 0 or not. If this condition is satisfied, then if statement will run block of code which is inside these braces. So for no, we have to move our robot forward. So we have to send, as I have said, if you want some voltage across IO pins, you have to use a register called port. So we are going to write on that register port D, because our motor driver is interfaced with the port D, equal to 0B 100100. So this when you write this to port D, our motor will move forward. Let's first understand why I have written this line. Now if you connect your motor directly to the microcontroller, microcontroller may not able to provide enough current to drive that motor. So we use a IC or chip called motor drivers. Now these motor driver are connected to the microcontrollers, and motors are connected to this microcontroller. So we drive motor indirectly with using this motor driver. Now motor drivers are capable to drive motors in both the direction, clockwise and anti-clockwise. Now the motor driver which we are using, which we have already interfaced inside our AVR development kit board, each motor driver can drive 2 different motors, and to drive each motor you require 2 bit of information. So you have to give 2 bit information to our motor driver, and accordingly it will drive that motor. So 2 bit we will get 4 different possibility, that is 00, 10, 01 and 11. Motor driver accept only these 2 possibility, 10 or 01. For these 2 condition, it will go into high impedance state. So if you give 10, motor driver will drive motor in one direction. For 01, it will drive in opposite direction. As I have said, we have used 2 motor drivers, so our board is capable to drive 4 different four motors, and all these 4 means 8 pins, so we require 8 pins of input. All these 8 pins are connected to the port D. This one is motor 1, motor 2, motor 3 and motor 4. For this tutorial and for all of the tutorial, we are going to use only motor 3 and motor 4, 2 motors to drive our robot. So in order to move forward, we have to move our left motor in anti-clockwise direction and right motor in clockwise direction. Left motor is connected to motor 3 and right motor is connected to the motor 4. So if you send 1 0, if you have connected the motor wire as instructed in the assembling section, you have to send 1 0 to this pin of port D in order to move left motor in anti-clockwise direction, and 0 1 to move right motor in clockwise direction. So in order to move forward, you have to send 1001 and 4 times 0 to port D, then robot will move forward. So we have written this section, which means if sensor is sending 0, then robot should move forward. If sensor is sending 1, which means obstacle is detected, we want our robot to turn left, we will write this in else condition. The way to do this is by writing our port D register with the value 1010 4 times 0. So by writing this value to our port D register, our robot will turn left. But this statement would be executed very quickly, so we want to include some delay factor so that it will turn left for a few seconds. So we are going to use a delay function. Now this M stands for millisecond, so any number written in this parenthesis, for that many millisecond it will wait, which means in this part it will turn left for that millisecond. We want our robot to turn left for at least 2 seconds, so we will write 2000. In order to use this function, we have to include a header file called util delay, so we have to write that include statement. Util delay.h. Now this header file should know at what clock frequency our CPU is running, of our microcontroller CPU is running. So we are using our microcontroller at 12 megahertz, so we have to define that 12 megahertz, 12 then followed by 6 times 0, UL stand for unsigned long. So everything looks perfect to me. Let's build our project by clicking on this. Okay, our program successfully compiled. Let's upload this program to our microcontroller.